Good morning. Today's lesson is on inequalities. We're going to solve inequalities using addition and subtraction. So write that down. We have had inequalities before, but we need to review them. So this is the symbol for less than. This is the symbol for greater than, so write that down. And these are the symbols for greater than or equal to. Greater than or equal to is this one. And less than or equal to is this symbol. And a graph of inequality represents, the graph of inequality represents all solutions of the inequality. When you have an open circle, it does not include that particular point. And we use an open circle with the less than and the greater than symbols. Then we have a closed circle. A closed circle does include that point. And we use a closed circle whenever we have the line underneath the symbols, less than or equal to, greater than or equal to. And if you don't understand, I'm going to show you an example in just a second. Addition and subtraction properties of inequality. When you add or subtract the same number to each side of an inequality, it produces an equivalent inequality, just like we solve equations. So let me show you an example. So example number one. Example number one says solve and graph the following inequalities. And we graph these on a number line. So what you're going to do is you're going to try to isolate x. So you have x plus 7 is greater than 2. So just like in an equation, we're going to subtract 7 from both sides of the inequality. This goes away, and I get x is greater than 2 minus 7, which is negative 5. Then to graph this, I would use an open circle. So an open circle at x is greater than negative 5. And the direction, all of the numbers that are greater than negative 5 would satisfy this particular inequality. So in other words, if I were to substitute a negative 5 plus 7, is that greater than 2? Well, no, I would get 2. And so that's why negative 5 has an open circle, because it's not included. If I chose a number like negative 4, plus 7 is greater than 2, I would get 3, and that would be a true statement. This is not a true statement, which is why you have the open circle there. So the solution is all of the numbers that are bigger than or greater than negative 5. Another thing you want to notice is that here you have, notice that your inequality x is greater than negative 5. Notice that your arrow is going to the right, and it matches the greater than symbol. And this is always true when the variable is on the left-hand side. If the variable is on the right-hand side, like the next one, it'll be the opposite. So let's do the next problem. I have x here, so I'm going to subtract 8 from both sides. And when I do that, I get an x on the right. I bring down the same symbol that I have up at the top. 10 minus 8 is 2. So that means to read, you would read this backwards. X is less than or equal to 2. So first of all, what kind of a circle do I do? Do I do a closed or an open? And if this would be a closed circle. So I would put a closed circle. This number line doesn't have any numbers, so I have to put a 2 there. And then because the variable is on the right-hand side, then my arrow is going to go in the opposite direction. So I'm looking for all the numbers that are less than or equal to 2. If you'd like, you can flip this thing around. You have to, in order for you to put x on the left-hand side, then you would have to flip the sign, and then you can rewrite it, and now it matches. X is less than or equal to 2. All right, let's go to a next example. All right, for example 3, you have 1p plus 2.4 is less than or equal to negative 3.7. it's the same thing. You're going to isolate the variable, so subtract 2.4 from both sides of the inequality. You get 1p, which we really don't need the 1, is less than or equal to, bring your symbol down, and then we're going to get a negative 7 plus 4 is 11, so I get negative 6.1. So here's my number line. First, I need to know what kind of a symbol I'm going to use. I'm going to use a closed circle because it's less than or equal to. And then I have a negative 6.1. And p is less than, so which direction do I go? I go to the left. And again, your arrow here, when you're graphing it, matches. These two match in the same direction. All right, next I have a variable on the right-hand side. So write this down. 1 4/5 is less than s minus 6 2/5. So this time I'm going to, add 6 2/5 to the right. And that means I'm going to add 6 2/5 over to the left. This cancels, and I get s is greater than, reading this backwards, s is greater than 7 6/5, and we can simplify that, which I'm going to do over here. So s is greater than 8 1/5. Now you can flip that if you would like, so bring the s over to the other side, which means you have to flip the symbol so that it reads s is greater than 8 1/5. Now you can graph it with an open circle and put 8 1/5, and s is greater than, and so that means our arrow will go to the right. And again, these match. Whenever the variable is on the left, the symbol and the arrow will go in the same direction. Okay, let's go on to the next example. Okay, example 5. We have a graph, so draw this graph in your notes, and you can see that you are going to now write an inequality represented by the graph. So I'm going to use x, and my arrow is going to the right, which means x is greater than, I have a solid circle, so it's greater than or equal to 6. For number 6, I'll start with the x. This time x is less than, because I'm going to the left there, or equal to, because I have a solid circle, negative 11. So it's just being able to read these graphs and write an inequality from the graph. All right, let's see if we have a couple more examples. All right, next, the last two problems are, of course, word problems. You're going to translate the verbal sentence into an inequality and then solve and graph. So example 7, write it down. You have a number increased by 4 is at least negative 12. So first we have to translate this into an inequality. So a number would be x, increased by would be plus. So x plus 4 increased by is at least. So what does at least mean? At least means it's the very minimum, negative 12. So it means it can be greater than or equal to negative 12. Now I have to solve this, so I would subtract 4 from both sides, and I would get x is greater than or equal to negative 16. So in order to graph, draw this in your notes. So you graph with a solid line, which direction is greater than, and that would be to the right. And notice you can also put the arrow above the line. You don't have to actually do it on the line. Example 8. Here we have luggage weights. You are checking a bag at an airport. Bags can weigh no more than 50 pounds. So you want to write that down. Bags weigh no more than 50 pounds. Your bag weighs 16.8 pounds. Find the possible weights in pounds that you can add to the bag. Okay, so let's see. Let's write this out. You've got 16.8 is what you're starting with. And then you're going to add some weight to it. So we're going to do plus x, and it can be no more than 50 pounds. That means it has to be less than or equal to 50, because it can be no more than 50 pounds. Now we're going to actually solve this. So we can subtract 16.8 from both sides, and I would get x is less than or equal to 50.0 minus 16.8. Okay, so when we subtract, we get x has to be less than or equal to 33.2 pounds. So how do we graph that? We do it with a closed circle, and we put 33.2. X has to be less than 33.2, so we're going to go to the left on our graph. And that is it for today's lesson. So now you'll have to get on My Big Campus, look for your homework, and we will see you in class.